Greetings, folks. Welcome. In this video, we're going to talk about how to make a scatter plot in Excel. But before we get started, there are a couple things you have to keep in mind when we're working with Excel. First, different versions of Excel look different. I'm using Excel on a MacBook Pro, which might look a little bit different than Excel on a PC. And second, there are different ways of doing things in Excel. The steps that we're going to talk about I think are great for beginners, but a more advanced Excel user might have some shortcuts to accomplish these same tasks. A scatter plot is a really useful tool for applied economic data analysis. It's used to show the relationship between two variables. On a scatter plot, you show one quantitative variable on the x-axis. This is a horizontal axis. And you show a different quantitative variable on the y-axis, which is a vertical axis. After making a scatter plot, you want to characterize its form, direction, and strength. For a scatter plot's form, you want to think about whether or not you can picture a line passing through the points. For its direction, if it has a linear form, is a line pointing up? If so, there's a positive relationship. Or is a line pointing down? If so, that's a negative relationship. And finally, for a scatter plot's strength, if you have a linear form, the next question is, are the points close to the line? We use a correlation statistic to measure the direction and strength of the relationship between the two variables in the scatter plot. The correlation statistic ranges between -1 and +1, and values closer to either negative or +1 indicate a stronger relationship. And positive values tell you that there's a positive relationship, and negative values for correlation tell you that there's a negative relationship between the two variables. When we get into Excel, after making our scatter plot, we'll calculate a correlation statistic. So let's say you have a variable that's in cells B2 to B501, and the second variable is in the next column over, in cells C2 to C501. The formula in Excel is equals Correl, C-O-R-R-E-L, parenthesis B2 colon B501, comma C2 colon C501, close parenthesis. As sort of a shortcut, you could also use the formula equals Correl, C-O-R-R-E-L, parenthesis B colon B. So that's telling Excel just to take the variable that's in the B column, comma C colon C, close parenthesis. So with that, I can't wait to get started in Excel, so I'll see you there in a second. Welcome to the spreadsheet. We have a couple variables that we're going to analyze. The first is college attainment. And this is the percentage of residents aged 25 and older that have at least a college degree. The second variable in the D column is per capita income. Both of these variables were measured in 2018. We have data for every metropolitan and micropolitan region in the United States. The data set we have 944 observations. Starts in Aberdeen, South Dakota, and Aberdeen, Washington. There's actually a great song by Danny Wilson called Aberdeen. Check it out on YouTube. And go from A's to the Z's. You see the second to last area is Zanesville, Ohio. I grew up in Newark, Ohio, and Zanesville was our rival in basketball and football. But I won't hold that against Zanesville anymore. It's been a long time since I've been in high school. And with these variables, we can look at the effect that college attainment has on per capita income in a region, which gets at the question of sort of the impact that human capital has on productivity. And this is a topic that's actually received a lot of attention by urban and regional economists. We can start by making a scatter plot, which is actually pretty straightforward in Excel. When you grab the two variables that you want to use in the scatter plot, Excel automatically takes the first variable and puts it on the x-axis, and the second variable and puts it on the y-axis, which is actually how we want the scatter plot to look. We want to have per capita income on the y-axis and the college attainment rate on the x-axis. But if you want it to look the other way, you would just have to flip the two columns, which we don't have to do. So we can grab the two variables. There we go. Okay. And go to Insert. I want to insert a chart, and I want to put in a XY scatter plot. And there we have it. We have a scatter plot. As always, I want to move it into its own sheet. Just makes it easier to work with. Let's increase the font size. And we'll increase the font size down here on the x-axis. We need to label our axes. Let's label the vertical axis first. So we'll change the font size. This is, whoops, per capita income. And now we need to label the x-axis, the horizontal axis. Change the font. And we'll do this percentage. Whoops, did I do that? Whoops. Percentage college attainment, 25 and older. We will change the, change the font size here for the title. We'll call it effects of college attainment on per capita income. U.S. metro and micropolitan regions, 2018, N equals 944. Oh, it fit. Very good. Oops. All right, there we have it. So there's a nice descriptive title. So we have a scatter plot. What should we do next? I'll give you a second. That's right. We need to talk about the form, the direction, and the strength. So first off with the form, can you picture a line going through these points? I can, and I think the line would go sort of right about here. So with the line, would you say it would be upward sloping or downward sloping for the direction? Yeah, it'd be a nice upward sloping line. And then finally, for the strength, once you have a line in here, do you think the points would be close to the line or far from the line? Well, actually, a lot of these points are really almost right on top of each other. So if you had a line going through here, the points would actually be pretty close to the line. To be more precise, we'll calculate the correlation statistic. So that's equals CORREL, the variable that's in the C column, the variable that's in the D column. There you have it, a correlation of 0.712, which is actually a pretty high correlation. You might recall that the formula for the correlation statistic is the covariance between the two variables divided by the standard deviation of the first variable times the standard deviation of the second variable. So just for fun, we will calculate the correlation statistic that way as well. Equals COVARIANCE, covariance of a sample. So we will put in the array C through C, D to D. This is the covariance of the two variables. And then we'll do equals standard deviation sample for college attainment. Then we'll do equals standard deviation for the sample per capita income. And now we want to take the value that's in cell F5 and divide it by these two multiplied together. So I'll say equals F5 divided by F7 times F8. And sure enough, you get an identical values to what we had just by calculating the correlation. So now we have the correlation variable. Might be a nice touch to go back into the spreadsheet and put in a little text box where we can say correlation, go back to the value, what is it, 712, relation 0.712, and let's enlarge the font. Oops, made it a little too big there. All right, so this is actually a really nice looking figure, nice looking scatter plot. We have a descriptive title. We've labeled both axes, and we've actually put in the correlation value. So that gives people a pretty good sense of the direction and strength of the relationship between college attainment and per capita income in U.S. regions.